Hello YouTube, welcome to our project which is an anti-theft device for CCTV cameras. This is not only meant for CCTV cameras but also meant for any device that is meant to be stationary inside a room, and this uses Arduino GSM module, Raspberry Pi and an IR and a wire-cut logic to establish the same. Let me go through the components that are being used in this project. This is the breadboard that's containing the logic for the first Arduino that contains the IR and the wire cut logic. The IR logic is nothing but a proximity sensor that senses the proximity to the wall. As long as it's in the proximity to the wall, it is good. And this is the second Arduino that is going to get connected to the second camera or the another device that is meant to be stationary. This is another breadboard that is going to give the logic for the second Arduino. This is a GSM module that's going to give SMSs and make calls. And this is the breadboard that is going to connect the Arduinos and the Raspberry Pi. The Raspberry Pi used here is a P plus model, and this is going to act as the aggregation layer. Let me just demonstrate the working of the second Arduino. This is the one that is connected to the GSM module. The other one is not connected to the GSM module. This is the wire cut logic. Once the wire has been cut, you can see the LED is high, meaning that the alarm is gone, and we'll be receiving an SMS on the phone soon. This is going to be followed by a call from the same number. And then we are just resetting the same Arduino to show you guys the logic for the IR. Initially, the hand is similar to the wall and the device is in close proximity to the wall, and once the device has been removed, that has been stolen, it is no longer in proximity, and the LED has gone high for the alarm, and we are going to receive an SMS, and this is immediately going to be followed by another call. The call is just to ensure that the person sees the SMS. And this is the demo for the part that is being done by the Raspberry Pi. Once the device has been stolen, your LED goes high, that is nothing but the alarm, and once the LED has gone high, the Python script that is running in the Raspberry Pi just displays the camera is stolen, and before the as email is received, you can see that the safety state is safe in the portal, and then once the mail has come, this is the state of the safe. And now once the mail has come, we are refreshing the portal to see whether the device is safe or not. You can see it's unsafe. If you go to the mail that is being sent by the Raspberry Pi, it says the device has been stolen, use this link to reset the safety. This is strictly supposed to be done after you ensure that the everything is gone right. Now you just reload the same portal to show that it's gone back to safe, and I'm just demonstrating the same for the second camera over here. So once the thing gets stolen, you can see that the Python script says camera 2 is theft and the mail has been sent. So once we refresh this portal, we can see that the camera is no longer safe. I'm showing you guys that the mail has come over here, and now once I refresh the portal that is meant for this camera, you can see with the URL saying camera equal to 2. You can see that the camera is unsafe. I go to the mail, and once all the things have been settled down, I use the portal that is link given in the mail to reset the portal for this camera, and all I have to do is change the URL to camera equal to 2, and you can see that this camera is now safe. Let me explain the codes that are involved in this project. The first one is the code that runs on the Arduino. This is going to be run on both the Arduinos, and it's going to be the same. Um, the first part is the process of initializing the variables to identify the ports to which the devices are connected. The LED buzzer is 5 digital 5, wire cut is analog 5, and the sensor read is the IR proximity sensor that is connected to A0. Void setup runs only once and it is used to set up the board. We are setting up the wirecut as the input and the LED buzzer and the as output and the sensor relay as input. The SMS function is used to send an SMS to the user. Change the change the ISD code as well as the number to send the SMS to your phone, and also the call function makes a call to the user, and you just have to change your ISD code and the number over here, replace the X by the number to send the SMS to your phone, and then the loop executes forever. And this is the main logic that resides within the Arduino. Like, if the IR sensor senses that the device is not in close proximity to the wall where it is supposed to be, or the wire cut has been triggered, then immediately the alarm is activated, the SMS is sent, and 3 calls are actually sent to ensure that the person actually sees the SMS. This is the code that is going to run on the Raspberry Pi. It's written in Python. The first part is including the necessary header files. The flag is used to ensure that the action is taken only once. And these are the ports to which the cameras are going to get connected to the Raspberry Pi. And then this is the part of just setting up the GPIO pins on the board. And then this is the one code that runs forever. If the Arduino sends a signal that is received by the Raspberry Pi on the appropriate port, then the action is taken. Like this value, if value is equal to 1, is similar to pressing a switch, but the Arduino is going to be the one that's sending the signal. So it is just a debugging statement to notify on the server stating that the camera has been stolen. And the main part is the send mail and the notify portal. These functions send the mail and actually notify a portal in the backend to identify the theft. So the send mail actually sends the mail. SNTP user and SNTP pass are the sender's user ID and password, and the to add is the address of the person to which the mail is supposed to reach, and modify the subject and the body as you like, but make sure that the header is constant, and then you do not have to change any of this code. Just type this and the mail will be sent. And then the def notify portal uses HTTP get to send values safe equal to 0 and camera equal to 1 to modify the file in the backend stating whether the camera is safe or not, and camera equal to 1, camera equal to 2 identifies which camera which is being under question right now. This PHP is the one that is going to run in the backend of the server so basically it gets the state of the camera as safe or unsafe via this get variable, and also it gets the camera that is being under question from this get variable. If it is the camera 1 and safe is equal to 0, it just puts the content unsafe in this text file. Similarly, if it is cam 2 and safe is equal to 0, it just puts unsafe in camera 2. Similarly, if safe is 1 and camera is 1, it puts safe in camera 1, and safe is equal to 1 and camera is 2, it just puts safe in camera 2. It's just that. And this PHP file is used to get the status of the safety. It is also done via HTTP GET request. The user just sends the camera for which he wants to know the safety or status of via the GET variable, and depending upon the content of the cam variable, the appropriate text file is read and it is displayed on the screen.